So we're going to start now, saying hello to everybody that came here today. I'll be talking about building an API service on Drupal 8. If Drupal 8 is even the software to use at these cases, does it provide you with the tools needed to accomplish such a project? Those are all the questions that me and my team asked ourselves when we first got this project, and then we moved on towards it. So just to introduce myself, my name is Jan Zavrl. I'm a Drupal developer at NDP Studio, a UK-based company that specializes in Drupal development. You can find me at my Twitter handle, Jan Zavrl, or jzavrl@drupal.org, and my website is also up there if you wish to contact me. So a couple months ago, a client came to us with a request. They had this old website, I think it was even in Drupal 6, and we already did an audit on it because they just wanted to know what's going on in the backend of the whole website. And we figure out that there's quite a lot of stuff going on in the background. They've got a lot of integrations to some outside services such as Salesforce, which is a CRM system. They've also got some e-learning platform integration with Moodle, and on top of that, they've got a couple of those, not just one. That is different instances of the Moodle platform. So they came to us saying that they'll be rebuilding their current website, which will be handled to a different company, but they would like us to do something that would be used together with their new website. And since we already did the audit, we know what the system did and what kind of stuff does it have inside. And they asked us to do an API service as a separate website, and an API service that would then be used from the new website to communicate to all of these outside services that they have. Now, a couple of reasons they had for this is they wanted to remove all of the logic that connects to the services into somewhere else, not to be a part of the website, because I mean, often, eventually, the new website that's going to be built is going to be rebuilt by somebody else or the same guys, and then again rebuilt, or just a new design or whatever. I mean, websites changes all the time, and they just wanted to have a standardized one point of contact website or a service that does all of the things that their current website already does. So they wanted this decoupled architecture, which when they came to us, we first thought that it might be a bit stupid, to be honest. But when we thought about it, the more and more, it was actually quite a brilliant idea. With this, they basically achieve this decoupled architecture. Everything that's being done with the services is in one place. They've also got standardized API points because they've got like different services. So Salesforce has its own API, has its own methods and parameters that you need to send. Moodle clients have their own completely different stuff. And on top of that, they've got Salesforce and Moodle both communicating with each other. So that's something that we also had to think about, and to have it all in one place as one system felt like a good way forward. So when we first got into our internal meeting with the team, obviously the first question that came up from the project managers was, what are we going to use to build this? And since we are a Drupal development company, obviously the first answer of everybody was Drupal, of course. But still, with the answer, it came a lot of uncertainty if Drupal is actually the proper way to do this. Because, I mean, at the end of the day, Drupal is still a CMS, as we like to call it. But it does provide us with quite a lot of tools, especially the new 8 version. It provides us with the new REST API. It has the Symfony components inside, which will be very useful to us when we do this. So eventually, we stick with Drupal 8. So then the work started. We first started with the boring stuff the boring stuff for every developer. We needed to first write the specification for all of the endpoints. We already knew what the system does in the background, so we just mapped out all of the endpoints or that we thought would be needed for the Salesforce, for the Moodle, and anything in between that needs to be done. And then we used a system called Apiary. I'm not sure if you're familiar with it. It doesn't really matter at this point, but it was just like a platform where you can create your own specification for APIs. It has good documentation. It even provides you with tests to the actual production endpoints or to the test endpoints and so on. So when the specification was finished, we started off with the proof of concepts for the service, and basically that went. I got the job to do the concepts. We just needed to know if Drupal was actually a sensible way of doing this and how hard of a time we would have during the project itself. And when I first started up the project, did the basic installation, stuff like that, I opened up the Drupal console documentation, searched for REST, and there it was, the one command that basically did everything for us. So I put it into the terminal, and what it gave us is basically the file itself. You put in all of the parameters that it needed. So what's the endpoint? What kind of a request are we accepting? Is it post? Is it get? Is it patch? Whatever. And you would just get this simple file that already has everything in it. So the next thing that you just need to do is enable that specific endpoint, and there you have it. So the whole proof of concept, I think it was done about half an hour, maybe less. I came back to the project manager and said, I think Drupal is actually quite a good idea. I'm happy that we decided with Drupal because it has all of these plugins and all of these components are just ready for us to use. We can just extend whatever functionality it has, the plugins, the API, and stuff like that. So, we're all very happy about it. And then once everything was finished, the specifications was there, we were certain that we can actually do this. We started off with the project. That means, like I said, starting up a new project, the new files, all of that stuff that comes when you start something new, the fuzzy feeling that when you install a fresh Drupal website. Then you set up all the architecture that you would need. The client's recommendations or the more demands or requirements was that they needed this to be a bit more extendable, pluggable, in a way that they can even turn off some specific elements of the service and decide will it actually still work. So currently we only had Salesforce and Moodle services inside, and we decided that it was best to split them up into 2 separate modules. So if they didn't want to use the Salesforce one for, I don't know what reason, they could just disable it and nothing would break. And then there were also the base classes, because we knew there was a lot of stuff, a lot of endpoints that we need to create. So each endpoint is its own file. And then, of course, you would need all of your services inserted as dependency injection. You would need a lot of, a lot of stuff that would be basically just replicating throughout each endpoint. So that's why we decided on base classes. We when I'm saying this, set up the architecture base classes, it didn't really go in that specific direction because, I mean, there was a lot of restructuring and reformatting. The base classes came as an idea when we already had quite a lot of endpoints in it, and we saw that we're just basically copying the files themselves and using the same dependency injection. So we had a lot of duplicate code, and that's why we eventually decided with that. So this is basically just the structure of the whole project. As you can see, we've used the project, the composer project structure. The whole site is hosted on Pantheon. That's why it has this YAML file here, and I think there's something else in the scripts, but that doesn't really show. Then we have the whole core stuff with the contrib and custom modules, and these are the Moodle and the Salesforce custom modules that we then created with all of the files inside and folder structure, which, I mean, I'll go on by with specific examples for at least some of the major ones. This is an example of the Salesforce module. And like you can see over here, so inside the plugin, REST, and resource, you've got all of these files, and each of the file represents one endpoint to the service. So we've got stuff like get order, get contacts, create contacts, update order. And, I mean, all of the things that they already had in their current website, we just basically mirrored them into this new structure. You can also see the Salesforce base resource. Like I said, this one was added a bit down the line, maybe a bit too late. We needed quite a lot of time to figure that one out, that we might actually do it like this, which is better. So this is an example of the resource, the base class that we created. So every endpoint that you create needs to extend the resource base class. So this was done before with each endpoint. And then, like I said, we decided that we would need to go in a bit more sensible way about it. So we created an abstract class called Salesforce base resource. The same thing was done for the Moodle part. And inside of it, we've got all of the things that is being used throughout the whole other endpoints on the system. Here, I mean, it's just some examples of what we did inside. So we defined some constants that were basically, these were, I think this is the object names to the Salesforce, stuff like that. And then we've even got our own custom, our own method that we created, because you would normally you would respond with a new resource response, and then the information that was inside that will basically output you back the things that came, the things that you requested from the whole endpoint. And then it was also this, so disable cache to the response. The thing is that GET responses in Drupal 8 in the REST API are all cached. Now, why we disable this is because, yes, we do still manipulate the information inside of these services, but the thing is that they can also manipulate the same information from outside of our service. They've got some, I think it was an iframe inside the Salesforce an account, and they could also do some stuff in there. So we actually needed to disable the caching for the GET responses, because we wouldn't be getting the actual things, but just the cached ones. The second one is the patch response. So with the first one, you do a resource response. And if you do a patch request, then the response needs to be a bit different. Now, the main thing is that this one already uses, it doesn't use the caching trait inside the class, so you don't get a cached response, you get the actual thing from the service. And we used this public methods to use it throughout our all endpoints to return the information to the user. So then we have the endpoints. This is actually the thing that then creates the endpoint. So you can see that we're extending our base resource. The class name is basically just a class name that, I mean, you can put it whatever you like. And the main thing is the annotation for this plugin. So you've got the REST resource annotation, the ID, which is something unique to this specific endpoint, the label, translation. Now, you won't be seeing this unless you enable the REST UI module on your Drupal installation, because normally when you do all of this, the system then recognizes this endpoint, but you would still need to enable it through the config files, and you would need to state what the authorization for this specific endpoint is. So when you do the label inside and enable the REST UI module, you get a nice UI which shows you all of your endpoints that you have, and you can use that to enable the endpoints, set up what kind of authorization you would like to have. We used basic authorization. And then there's the URI paths. So this is the thing that we had. We also decided to prefix all of them with the version number. We didn't expect this to change anytime soon, but we decided it was a good thing to put it in anyway, because eventually something will get updated, or even maybe Salesforce and Moodle will get updated, so we would have to eventually do something to it, and it would be good to sort of separate the existing ones to the new ones with the prefix. Then you can put in whatever you would like here. So we added Salesforce/orders/ID/property. These are the parameters that the user that requests the service would have to input. So the first one would be the ID of the order, and the second one would be the property. So the way we thought about it is, so this is the get order resource. So you would put in the ID of the order that you would like to have received, and also the property, which we made optional. And it would work like if you put the property in and use the proper property of the order, you would only get that specific property that you wanted to receive. And then this is the public methods inside each of the response. It can have the get, it could be post, it could be patch. So whatever kind of methods you would like to have, you would just need to put in the public method of this. You would also need to put in the parameters as they are in the endpoint. So like you see here, we've got the ID and the property, and you need to have the same thing inside your parameters. Why is it the other way around? Don't ask me, because I don't know why does it work like that, but it just did. And then inside, we used all of the stuff that we already injected with our base class. So this is the Salesforce helper service that we created and then injected it into the base class, and we already have it used like this. And these are just the methods that the service provides us with. And then we would return this and the response, which is again the public method from the base class, and then the response that we would get from the get order. So the next one, I mean, this one is pretty much the same one. This one is just created for, I mean, I've added it as an example because there is some issue with the REST plugin, and the only difference between the previous one is that this one has a second line here. So whenever you have post endpoints or methods, for some reason you need to put the second line in I think if I remember correctly, it was because it collided with their existing entity endpoints. I haven't actually checked this yet, but I think this might have been fixed with the 8.3 module, because I know that the entity endpoints have been changed a bit as of recently. And then again, the post public method inside the class itself, pretty much the same thing as it was before. The only difference here is that you accept an array of data. That is the thing that you post on the service. And then again, the Salesforce helper service, create order methods inside the service, and then you respond to the requester with the response that you get back. Then it was, so we had all of these endpoints set up and they were working quite well. The next thing was that we needed to create the connections. So we had the Salesforce service, and then we have the Moodle service. The Moodle one even had several different of them. So we needed to have something that would store all of the credentials that we would have to put in. So Salesforce has something, Moodle first entity has something, second and third, and so on. And then we just had to implement them in the endpoints, again, using with the base classes. So this is an example for the Salesforce subform. This is just a basic config form base. It doesn't provide you all of the code that we had, but I just put in some of the examples so you would get a clear idea on what this pretty much is. So again, if you use Drupal console, most of these things can get generated for you. So the main thing is that you need to extend the config form base, and then inside the build form method, you just put in the form with the form API structure that we already know from Drupal 7. And then again, in the submit form method, what you just need to do is take all of these values that have been submitted and save them somewhere. And this would be saved in the config. The Moodle ones were a bit more complicated because, like I said, you could have several of these. At the current time, I think they have 3, and they even said that they would maybe add one more or maybe remove one. So we had to use a different approach. And what we did is we created a config entity type. A config entity type is very similar to the content entity type. So as you may know it from, which is a node, the nodes are the content entity type. But the main difference between those two is that the config entity type also implements with CMI, so the content, the config management, and also it doesn't have any fields, whereas the node ones, you could add fields to the nodes, the bundles of the nodes. So we did a custom entity type, and this is the annotation to the whole thing. Just to give you a couple of them. So ID is the machine name, the label is then the human readable name, and then you've got the handlers, list builder, form, and route provider. List builder, very quickly, this defines the class that provides you with the list. So for example, when you go inside, let's say admin content, and where you see the list of all of the nodes, that is a list builder function that's being called, and it provides you with the list. With the content one, that's a view. But if you go into any other, say, custom entities and stuff like that, the list builder is the thing that provides you with the list of all of your current existing entities. And then you have the forms. So the add new form comes from this class, the edit form comes from this class, the delete form comes from this class, and so on. So all of these annotations gets read by the system, and stuff then just works inside the system. This is just another example. So inside of the Moodle Client class, which was made, we had the get soap client. So every time you would load this specific entity that you would need, which is the Moodle instance that you would set up, you could also call then the get soap client, and it would return you the instance of this entity. So we had the endpoints in, and we have all of the connections made. So right now it all comes down to putting all of the logic together that they needed. So they had some simple stuff like I showed you before, which is the get contact or the get order, which just retrieves the information from the services. But they also had a bit more complex things like create order, which may seem very simple at first. It was to us as well. But when we got in a call with them, they just showed us like this 700 line of code, which is, I think it was a class inside their Salesforce, and it did things like even with the accounting. So a lot of stuff was involved with that. And then the next thing was we had to standardize the input and output parameters. What this means, like I said before, the Moodle and Salesforce APIs are very different to each other. So the parameters that you would send or get back are different to each other. And the whole point of this project was to standardize all of this. And then the next one that would build the website could use a very standardized parameters to input and output into the services. So what we did here is put up, I mean, it was quite a simple thing then. It's like a mapper thing with an, say, yeah, basically arrays inside with a key and value thing. So the keys and values would be just mapping the parameters that we would set, the new clean ones, to the parameters from the service. I'm not sure if anybody worked with Salesforce before, but their parameters are, I mean, it's even very hard to read them. There's no consistency between them, and it's just basically a mess. So we had to build this sort of like a mapper thing that would then be again injected into all of our classes that we would need. So you would just put in the stuff that you, for example, got from the requester, put it into the mapper, and you would get back the parameters that you would need to then send to the service, because obviously you would need to use the parameters of the service to get the proper information back. Again, all of this was done by using services and dependency injection. And we also had, like I said, the systems, the services had to communicate with each other. So Salesforce is a CRM system, and you've got Moodle, which is an e-learning platform. So there was a case where, for example, the user buys something, which is e-learning something, and once you buy that, you also need to get credentials or access to that specific e-learning platform. So it's important that we have this bridge between the two modules. And it was all fine, but we had in mind that we needed to make this completely independent from each other. So if they would, for some reason, again, disable the Moodle one, the Salesforce would still have to work. Again, Symfony and Drupal came to rescue with its events and event subscribers. So we would just define the events that were inside. Whenever we need to communicate with the other system, we would dispatch this event, and the system would pick it up with the event subscriber and then did its own logic, whatever it would need to. So this is an example of the Salesforce Mapper service. So it's just a class like any other service. And then we've created this public method, get mappings, with the type, and then quite a long switch statement, which would provide you back with all of the information that you would need. So this would be for the account, and the mappings would be in this account mapping private method. I think I have it here. No, I have the contact mapping. I mean, it's the same thing. I just wanted to show this one because because of this piece right here. So with the even in third-party services with Salesforce, you've got a lot of references between different objects. And like you see here, this is the object that holds the contact information. And each contact can have subscriptions and external credentials. At this point, it doesn't really matter what these are. What it matters is that these are separate objects in Salesforce that just connect to the contact by, I think it's the ID parameter. So what we did here, these again have its own mapping, just like this one you see here. But so we can have a separate subscription mapping, same method like you see here with its own parameters and stuff like that. And then when you would call the get contact mappings, you would get all of these inside, and also the subscription and external credentials, which would come from different methods. And then inside, I think I have it here or here. Anyway, I'll get back to that. So when you do this, you get a whole structure of the mappings, which is all nice. And then we have inside of our helper services, we have the map data method, which just takes the mappings, the data. So the mappings are the things that I just showed you before. You would have to retrieve it from the mappings service. And then the data that you would either get from the requester or from the service. And it would just loop through the data and then map it properly to the array that would be given back. With the reference objects, like I showed you before, it was a bit difficult to understand the whole thing. But we did it in a way, so with this you get the reference mapping, and then you would basically just see if it contains an array, which means that we also need to get a different object that the one we're currently requesting. So in the previous case, it would be the subscriptions. And what it did, it basically just does another request to the service. We have the ID of the parent, because that's the ID that's being used to reference both the objects. Does a request, and you get back the result, which is the new reference object. And then you just use that one, put it inside your original mapping, and you have all of these structured mappings. Now, I mean, there's a lot more going on, but these are just the main things that we had and we had issues with. So when we got all of these things together, it was just a matter of deploying to multiple environments. Of course, the client wanted to do some testing, to have some staging environments, and then the production environment that would be actually used on the one. Like I said before, we used Pantheon, which gave us a lot of this already. It's very useful to, I mean, it's just clicking and you would have multiple environments. Then there was the issue of several credentials. So with the Moodle and Salesforce connections, we would have some sort of credentials inside. And what we were using for development were, of course, the development credentials. And when we would put that to a production environment, these credentials would need to change. Now, since we used config entity and config form, those credentials would be actually saved inside the config YAML files. And then with the deployment workflow, those would get overridden and so on. So what we did, we had to ignore the configuration files. And by ignoring, I don't mean git ignore, because that would just remove the configuration files all in all, and it would just delete the config on the production. But we used config ignore module, which is a very useful thing to have. I think we use it right now on every project that we have. You basically just say which of the config files need to be ignored. And once you do the import, it saves the config in its previous state before the importing, then does the import of all of the things that are changed inside, and then it looks back into the current state that was saved, and it checks which of the configuration files need to be ignored. So it takes them from the previously saved state and imports them back, so you don't get any overridden imports. So that was roughly about it on the whole project itself. Like I said, it was quite a lot of other things involved, but these are all the major ones. We proved to ourselves that it is possible to use Drupal in a very unorthodox way, such as having it for an API service. So thank you for being here. Thank you for listening. If you have any questions, let me know. Nothing. I have one there.
Hello. So have you tried the JSON API module for getting and posting REST resource? Maybe for this.
I think that one was more. It was more popular in Drupal 7, right?
No, no, its release is right now for Drupal 8 JSON API. So it will give you the ability to fetch and post also by default for all entities and bundles inside Drupal 8.
Well, yeah, but that would be for the entities inside your Drupal system.
Yes, yes. I didn't meant about this project, but in general in your company.
I think I've only read about it. I've seen it, but I don't have that much knowledge about it to actually comment on that.
Okay, thanks.
I have also one general question with regards to this implementation that you mentioned. I know a little bit about APIs, but not much. So I'm wondering if you have a scenario where you have an e-commerce site and you have ERP system on another side. When a new order comes, what's the best practice in regards to API? That a cron job on ERP system come to Drupal API to grab that order, or when the order happens, they need to be, pushed to ERP API.
I think it really depends on how would you like to store all of that information. Because we had not with this one, but I remember we had some similar issues before. Because with Drupal, once an order comes in, it doesn't actually mean that order is like completed. Because you might have an outside service for payments, so you would get away from your Drupal site and then brought back to the site, and only then the order would be actually completed and finished and ready to be put inside the CRM or the system.
Let's say that when customer care approves this order, so do we need to push it? It's a best practice to push it to another system when we need to sync it, or to wait that other, ERP system come here and utilize our API.
Yeah, I think I understand. I think the best way would be, because with Drupal you have all of these hooks or events, so it would be best to find the actual hook or event that gets fired after the order completes, and use that to push the data into the ERM system. Because if you would do it the other way around, you wouldn't get real-time information back, because you would have to set the cron job for, I don't know, 15 minutes, an hour, 12 hours, whatever. And with that, you would also need to set up like a route or an endpoint on your system that the other system would then communicate with. And then, I mean, it just brings a lot more complexity doing it the other way around, unnecessary complexity, because you already have these systems, the hooks and the events, and you should just use that, because at that point, you already have the order prepared for you. So you just need to, I don't know, maybe manipulate it a bit and then push it to the service.
Thanks.
Like a question, during your research, when you do this proof of concept, have you tried to consider this GraphQL? Because there is this GraphQL initiative about REST API in Drupal, which will like replace it. I'm just wondering if you tried it, because I don't know if anybody just uses it now. Because there are so many talks about it, the blog posts. I just want to know if you compared it to REST.
Honestly, we haven't. The first thing that we thought about, because I had some knowledge about Drupal 8 and the REST API, the way it is. So that was my first thing that I went after. I didn't really consider anything else, because at that point we already went on and decided that we would do this with a Drupal way, right? So the most sensible point, the most sensible thing at that point that we had was to use that. And once we did it, we proved that it could be done. We just went with that, because it was working. It was like the proper way at that time to do it. So we haven't actually given it any thought about using anything else.
Okay, thanks.
All right, thank you.